Electrochemistry. Electrochemistry is that branch of chemistry which deals with the study of production of electricity from energy released during spontaneous chemical reactions. These spontaneous chemical reactions they occur in galvanic cells where chemical energy is converted into electrical energy, and the use of electrical energy to bring about non-spontaneous chemical transformations. These chemical transformations they occur in electrolytic cells where electrical energy is converted into chemical energy. This means electric current is passed through electrolytic solutions, and that leads to the dissociation of electrolyte, and various chemical reactions occur inside the electrolytic solution. Now, what is the importance of electrochemistry? This Here we study about the production of metals like sodium, magnesium, calcium, aluminium, electroplating, purification of metals, batteries, and the cells used in various instruments. There are two types of cells, galvanic cells and electrolytic cells. So these two types of cells will be studied in detail in electrochemistry. Galvanic cells are those in which the chemical energy is converted into electrical energy, and electrolytic cells are those in which electrical energy is converted into chemical energy. So basically electrochemistry deals with the relationship between electrical energy and chemical energy. Now we will study about the construction of a galvanic cell. This particular galvanic cell is termed as the Daniell cell. Here there are two half cells, one this one and one this one. These two are called half cells. On the left hand side, this is called anodic half cell, and on the right hand side, this copper sulfate solution, it's called cathodic half cell. So here in anodic half cell, a zinc rod is placed in 1 molar zinc sulfate solution. This is zinc sulfate solution. And in cathodic half cell, copper rod is placed in a solution which is 1 molar copper sulfate solution. Here a voltmeter is connected via these wires, and here salt bridge is also put here. Now this at anodic half cell, this one left hand side, here oxidation occurs, that is loss of electrons. Zinc loses 2 electrons to form Zn2 positive ions. Zn2 positive ions remain in the solution, whereas electrons are pushed towards the external circuit. So electrons they come out from the zinc anode and enter copper cathode. And here at cathode, reduction, that is gain of electrons, occur. Copper 2 positive ions gain 2 electrons to form copper. So on left hand side, this anodic half cell, here oxidation occurs, and on the right hand side in cathodic half cell, reduction occurs. Salt bridge. Salt bridge is an inverted U-tube like structure. The tube is filled with concentrated solution of an inert electrolyte. The electrolyte does not undergo any sort of chemical reaction, nor does it react with concentrated solution in the two half cells. Most of the time, salts like KCl, KNO3 and NH4NO3 are used as electrolyte. Salt bridge is constructed by filling the U-tube with a mixture prepared by mixing agar-agar or gelatin with a hot concentrated solution of electrolyte. Now there are more functions of salt bridge which we study here. Now the salt bridge, as I told you, that the solution of electrolyte is filled within the U-tube, and a little amount of gelatin is also added. The apparatus is then cooled, and consequently the solution fixes within the U-tube in the form of gel. This prevents the intermixing of fluids. The either ends of tube are then sealed using cotton wool in order to reduce diffusion. The important function of salt bridge is to complete the electrical circuit as it connects the electrolytes in the two half cells. It avoids the chances of diffusion of solutions between the half cells. And last but not the least, a very important property of this, a very important, we can say, function of salt bridge is to maintain electrical neutrality by providing a path for movement of ions. Like if we draw this with two half cells, and here a salt bridge is there. On anodic, this one left hand side, anodic half cell, as the time passes there is more and more concentration of zinc ions, positive ions are there. So the solution may become positively charged, this one. So at this time the anions from the salt bridge, they move towards anodic half cell to keep it neutral. In the same way, on the cathodic half cell there is more and more concentration of negative ions because copper gets deposited on the copper rod. So here cations from the salt bridge move towards cathodic half cell. So in other words, we can say that these anions, they move towards anodic half cell from the salt bridge and cations towards the cathodic half cell, and this way the electrical neutrality is maintained. Cell potential. There exists a potential difference between the two electrodes, and as soon as the switch is in the on position, the electrons flow from negative electrode to positive electrode. Or we can say this anodic half cell. Anodic half cell is what we call negative electrode. Electrons flow from anodic half cell to cathodic half cell. The direction of current flow is opposite to that of electron flow. The potential difference between the two electrodes of a galvanic cell is called cell potential and is measured in volts. The cell potential is the difference between the electrode potentials, that is reduction potentials of the cathode and anode. There are two types of potentials, reduction potential and oxidation potential. But by convention, electrode potentials are considered to be reduction potentials. So the two half cells, if we consider copper and zinc like in the previous case, one half cell has got a higher reduction potential and the other has got lower reduction potential. So there is always difference of potential between the two half cells. It's called electromotive force, EMF, when no current is drawn through the cell. It is now an accepted convention that we keep the anode on the left and cathode on the right by representing the galvanic cell. Anodic half cell or this negative electrode is kept on the left side and cathodic half cell or positive electrode is kept on the right hand side.